Hi, my name is Himat Khalsa, and I'm with the Building Construction Technologies Department at Pima Community College. And we're here at the home of Ed Maru to continue on with our lecture series on sustainability. Today we're going to be meeting with Paul Schwam, who is an architect as well as the developer of the machinery that we use in the process of lavacrete or scoria. So let's go on and take a closer look at this building and meet Paul Schwam. Hey Paul, how you doing?
How are you?
Good to see you.
Thanks for coming by.
I really appreciate you taking the time to meet with us today and to show us the lavacrete in an actual building, a scoria. So I wanted to discuss a little bit the material here, and then maybe we can take a walk around and see the overall building, the architecture.
Sure.
So what are we looking at here? A lot of our students have no experience with lavacrete or scoria. Can you tell us what it is and how we end up with a wall like this?
Sure. I think we ought to start with the fact that lavacrete is a spec concrete, but it's a whole family of new kinds of concrete because this is very lightweight. It's batched in reverse than regular concrete, so you get a different quality product, much better for architectural services. And as far as how we build this is we're using volcanic cinder, which we call scoria, which is kind of the premier product with this lava product.
How is it formed?
Well, generally speaking, it's like rammed earth. That's the best way to think of it, only you don't have to ram it. And it's a lot stronger. You can see that it's very durable. I mean, it's as strong as concrete, it's just also full of air.
But the forms that you're using, are you using steel forms, aluminum forms, wood forms?
We've tried a lot of things, and what I prefer the best is just 3/4 plywood forms because it's the most flexible.
Right.
We can do straight walls like this, or I can show you some curves down here that kind of give you an idea of what kind of undulation. And there's a lot of curves all over this whole place that's only available that way.
Yeah, so flexible and forming. And why is this sustainable?
Well, this is a mass wall. This particular wall is 18 inches thick, and so it gives you that same sustainability that adobe will. Only the material is stronger and will last a lot longer. Plus it adds more insulation. It's actually got little air pockets of air through this whole thing. This is a solid wall from outside to inside, and this isn't plastered. This is the natural color of this. So I worked hard so that this lava wall and scoria has the same quality of like rammed earth and adobe, so you're looking at the real thing. Right. And it's real all the way through. It's real color. It doesn't fade out anymore. It faded out 10,000 years ago, so it's not going to fade.
And that's what I love about it, because from the sustainability standpoint, of course, what you're talking about here from the mass standpoint is it means that it's holding temperature. Internally, if you put a little bit of conditioning on this, it's going to be a battery and it's going to hold that cool. Also at night, the cool air is going to hit this surface and then work its way to the interior. And so I love that about it. But the other thing I think that sometimes is missed by some is that this is an integral product and that you never paint this. You never maintenance this. So a lot of the things that we do as far as material use, we can avoid in a product like this because this is integral and no maintenance involved. So
this is made of volcanic cinder. It took a volcano to make it. Okay. So it's also structural. So it becomes the structure. It is also the insulation because it's so porous. The whole thing is fireproof. I mean, the same material is used for fireplaces and whatever. And of course, the color doesn't change. And in fact, is you could do a remodel on this and take out, put a pattern in here, and it's going to be the same color as this. It's solid all the way through.
Yeah.
So
let's talk a bit about the structure, just so our students understand. This is the scoria, and it has a percentage, maybe 18 to 20% of cement, right?
Yeah, if you measure it by volume.
Okay.
Yes.
And then we also have some rebar in here.
Yes.
Right. And so is the rebar pretty similar to what you'd use in like a plain concrete system? Like, what does this have in here as far as rebar?
Well, fundamentally, most of these walls fall under what they call the plain concrete code. I'll get technical on you, which means you don't need the rebar except for around windows and doors and things. When you want to do a span like over a window and door, then you put in reinforcement. That changes the code into the reinforced concrete code. It's all the same to me. It's the same material, same steel. So I can minimize the steel here, and anytime I need the structure, I put it in and it becomes as strong as I need. Now, that's useful to me because I don't have to actually switch gears on what exactly I'm doing. And although I do put steel in this, usually number 4s at 48.
So half-inch.
Half-inch rebar. 4 feet on center, vertical and horizontal. And that's not for structure so much, that's just for the conduits and everything I'm attaching to all that. Just makes the whole process easy.
It's a good point, and it brings up another point of discussion, is the utilities. So you're obviously running conduit in the walls, and the electrical outlets protrude from the wall, just like in a concrete wall.
Right.
Yeah, okay,
Right.
so that's roughed in before you pour the
Right.
scoria.
This process kind of reverses the construction process entirely. What I do is I form up the inside surface and I form up the outside surface exactly where I want that. And ordinarily in construction, you're having to, let's say for frame and block, if you wanted to run a wire or a conduit through there, then you're actually drilling holes through wood or chipping through concrete in order to get the conduit and or the wire, et cetera, et cetera. In this case, I form up the inside, I form up the outside. You put the electrical where you want it. Conduit goes in without alteration. So you put the conduit in, and the plumbing is in the easiest possible situation. There's nothing in its way. And then the concrete itself fills in all the gaps, and it holds it all solid. So that makes both processes easy. So there's a lot of time savings just in this. And the fact that you're doing everything goes together in a single pour. I mean, we do this in lifts about every 2 feet, but once we get that poured, it's finished from inside to outside, everything.
So let's talk about finishing, because I know there is a bit of a process. We don't paint this necessarily, but you do seal it. So let's talk briefly about that, as well as, if you could, the idea here, we were going to talk about these medallions here and the difference in a milling process versus sandblasting.
Right.
So let's touch on that a little bit while we're here, and then maybe we can look at the overall building.
Sure. Well, the overall process has been evolving a little bit. And so let me just talk about the medallions in this finish. This is a natural finish, and it's so porous that if you put a hose on here without sealing it, that at full blast, it'll get down about this far before it soaks all in. And so you obviously have to seal that against rain and that kind of stuff. So I just use a regular block sealer to seal this, and it stays clear. Block sealer kind of absorbs into here, and then it stays out of the sun, so it doesn't break down, lasts a long time. Now, these medallions, this is just part of the forming system. It's just a clip that holds the plywood even as it goes on up. And so, as you can see, each one of those joints is roughly a plywood lift. And so that's what creates this aesthetic. Now, this particular finish, speaking of finishes, is sandblasted. Sandblasting kind of ages it a little bit, and we kind of wanted to age this house a little bit, so that worked well. But you could plaster this. Fact is, you only need a single coat of plaster, just the color coat, because it's so sound that you don't need to have a scratch, and you don't spend all the money on regular plaster because it's
really
plenty strong. I mean, I've done some. Fact is, I've finished homes where all I've done is just sprayed on a color coat of cement and water, and with a little bit of color in it.
So if somebody wasn't totally taken with the color or the overall look in all places in their house, they have the flexibility to use these other systems.
Sure, and I've done things like staining it before, and I've got systems where, mechanisms where I use a more coarse aggregate. This is 3/16, which is rather fine, but I can use a 3/8, which makes this even more porous, which means you have to plaster it. But you can plaster it, squeegee it down to the aggregate, and then mill it again, so you bring out the lighter color of the plaster with some of this natural color in the background. So there's lots of options. It's how much you want to play with it.
Right.
And you can, after you get a wall done like this, I've had people they have a special etching that they want to place, and so they can put a template up here and sandblast actually some depth into that and actually create some artwork that's fairly easy and just beautiful and all the same color. It's just it just works universally.
Great. Well, let's take a look at the overall building then.
Okay.
So Paul, I know you have a bit of a signature that really does express some of the possibilities that we can do in scoria with the reliefs, and this is sort of a signature mark that you put in all of your buildings, Father Time. Can you tell us a little bit about that?
Yeah, this signature right here is just an example of what kind of artwork that you can actually cast into the wall easy. Now in this particular case, it's Father Time. I think of Father Time because this material is going to last for thousands of years. Now, I require one of these in every building I do as a signature. And I think of it as sort of building a soul into this building, because this building is going to be here a long time, longer than any of us. And so I require it. And if for example, the architect or the owner do not really want to see it anywhere, what I do is I cast that in ice, and then I cast that maybe inside the wall, somewhere near the front door. And the ice melts out, and you can actually find it because it'll ring slightly different when you're looking for it, so you can tell that that's signature and this is my building.
So the soul is still there. It's just not revealed.
Exactly.
Great. Let's take a look at some of these other features here that are somewhat unique to scorias, at least as far as how simply you can do them. How about this curve here?
Well, the forming I use is very simple. It only uses 3/4 inch form. It only needs 3/4 inch form. Most concrete needs way more, like a lot of stiff backs and 2x4s to keep this straight. Rammed earth needs a whole lot of reinforcement. This doesn't. Think of this as almost clay. It goes in really dry. When you really just sort of can use your fingers and your gloves, just make sure that you get all the cavities, but it doesn't create any pressure against the form. And so if a wire breaks, and all I use is baling wire between, if something breaks, nothing happens. So it's not dangerous like regular concrete. Anyway, it also allows you to do things like these curves, all these kind of details, ins and outs. And
arch.
yeah, and on the inside of this window, it's actually compoundly curved. And you just can't do that kind of stuff with regular forming without costing a ton.
Wow. And let's go over here and talk about a window detail, because I'm sure some of the builders that are viewing this, they're going to be curious about how you detail the windows. You're forming this up. How are the windows set in, and what sort of detailing do you use there?
Well, this is the very simple buck. You have a buck that really creates this inside form that slips into the wall forms, and that's what creates this shape.
Okay.
But then what you end up with is just a flat surface that you can lag and screw into, and you can get some grout that matches that. So it's almost seamless. I've even done some windows where the profile is more complicated, and you can direct set glass from the inside just by coming up against a stop. So there is no frame. I mean, you can play a lot of tricks with the material because it's so easy to form.
Yeah.
So
Yeah, and this would be considered a real minimal finish, which is kind of popular these days.
yeah, it's very simple, and yet the lines are still clean.
Great. Let's walk over here maybe and get a look at the whole building.
Yes. Yeah. So one of the things I wanted to point out was, with this particular product, you can get some amazing detail. That feather, for example,
really finely detailed.
that was a rather quick mold that I put in, similar to the one down below. And if you can see those very gentle curves. That's something that's also easy to do with this material. And last is the cooling tower. Now, this is a cooling tower is essentially a very ancient method of cooling a building, and it makes sense for Ed here because the house is all solar. He's doing as much sustainability as possible. In fact, he found this product due to sustainability, and he's using everything he can. And so the material does that, the cooling tower does that.
How does the cooling, for those that aren't familiar with that, how does the cooling tower work? What is involved with that?
Up at the top of the cooling tower, you can see those windows. Just below those windows, there are some misters that introduce water into a chamber that just drops down. That adds more weight to the air which begins to drop down. There's an opening at the bottom, and so that cool air just naturally drops down here and flows into the building, and all the hot air raises to the top and leaves, and the cool air just starts filling this house with cooler air.
Beautiful. And it also adds a nice architectural feature.
Yeah.
I wish we saw more of those in this climate. Before we leave, I want to make sure that you have a chance to see the manufacturing process, because it's important to how lavacrete is made. Paul has asked us to take a detour to where he stores the product as well as his equipment, and he's going to show us how this is all done. Let's go take a look. So we're talking about lava. Let's just start first with why lava? What is that? That's an acronym, right?
It is LAVA, L-A-V-A. It stands for lightweight aggregate vertical application concrete, lavacrete. Reason is because regular concrete is very fluid and it's perfect for floors. And there's almost no reason to take that floor up unless the house or the roof fail. Then you take the floor out. So if we could just make the walls and the roof as durable as the floor is out of concrete, then we'd have houses that last for thousands of years. Really worthwhile. So this concrete is specially formulated to give it a sandcastle quality. So it's intended to go vertically easily. And so then you simply, therefore I'm in the sandcastle business. That's all I'm doing, is I'm trying to learn how to cast material that's essentially like sand into vertical architecture.
I think if the students wanted a reference, or somebody wanted a reference to look at in what is possible with that, they could probably look at the work of Gaudi.
Yeah, probably. I think there's Gaudi. He used a lot of gravity in his design, actually, which is similar to why we make vaults out of adobe and concrete and rammed earth, and this is very similar. It's just sandcastle quality. If you can imagine it, you can cast it, and Gaudi's probably one of the best possible examples of that.
Great. And tell me a little bit about the scoria, the material that you're using in this process.
So this is the scoria. You can see it. This is 3/16 red scoria. Typically volcanic scoria is and or cinder comes in black and red, a couple different varieties. Scoria is a geological term. In volcanic world, they have tuff, which is the lightest. They have pumice, which you've heard about, which is a little heavier but lighter than this. Then they have scoria, that's this, and then cinder, and then basalt. This is the material I prefer to use, either the cinder or scoria, and they usually don't make much of a differentiation, but because it's structural. It's good insulation and it's also good structure.
Let's just, since you use those two, let's talk about just the difference between the cinder and the scoria. Is it really just the size of the aggregate, or
it's the weight of the aggregate? It's a density.
Okay.
It's a geological density, and most people at the construction level don't differentiate between the two. In New Mexico it's called scoria, in Arizona it's called cinder, typically.
But this larger aggregate, the scoria, you like this because it has more insulative quality and
structure. I would say that all of the volcanic materials are preferable over sand. You can build with sand. I have built houses with sand. So the idea is you want to get the dirt that's local around you to be able to build your house. However, volcanic cinder, let me put it this way, natural lava coming out of the ground, when it creates all these otherworldly shapes coming out of the ground, kind of this slow flow, it's actually doing two things. It's creating a matrix to hold water and nutrients for plant life, and it's also creating cavities, insulated cavities for animals, for animal life. So it's a matrix for life, and it works best really with volcanic cinder. Cinder, I think, is the best ecosystem that you can create, and so that's why I'm using it. I mean, think Hawaii. Yeah. So this is kind of the what I would consider the premier material for this lava machine.
Let's talk about some of the things that I know the audience will also be interested in, like utilities. What are the advantages of your system as far as running utilities? How do you do it? How do you get the electrical and plumbing and that type of thing in the wall?
Part of this solution is in recognition. That's a big question. Let me go back and sort of explain this a little bit. The building methods we use today were developed before there was electricity, before there was plumbing, before there was any of this, any of these utilities that you're talking about right now. So as the utilities are being integrated into today's construction, we've got to drill holes in the wood and in the brick in order to install all that. So it takes a relatively simple project of putting a wire in a wall, very complicated when you got to mess with the structure itself, which is supposed to be permanent forever. So what this does is this reverses this process. All of the utilities can go into the form without compromise. There's nothing in the way of that. And then you cast them into place using this material. When you pour this material in the wall, it kind of finds itself all the way around that, and it does the construction itself by enclosing all that. All the operator has to do really is just make sure there's no small voids here and there. So it's actually very simple on both processes here. And so that's extremely important in saving time and effort in construction.
Great. So we're standing here in front of the machine, the conveying system that you created. What are we looking at here? How does this work?
Well, we got cinder on one side, or scoria.
So this chamber here is cinder.
Yes, from here on lava, or scoria I'd call it. From here over is all cement, and then we have a source of water going in here. The same three ingredients for regular concrete.
So it's a batcher.
It's a batcher, but it's unique in that it reverses the batching process as well. That actually gives you a new family of concretes. In other words, I'm not looking for the fluid concrete, I'm looking for the sandcastle concrete.
And why is that, just briefly?
Well, because you need it for verticality, and in order to get that with the machine, what I do is I saturate the aggregate with water first, add the cement last. That's reversed than the regular process. So what that does is that gives me a good sort of malleable cement to work with, like sandcastle, without getting too watery and still having all the water you need.
And some from the batcher, then what happens?
Well, this is the batcher, and this is controlled actually from the guy who was on the wall, and he's got his own switching. And what he does, he simply turns it on. It's already been dialed in as far as how much water and how much cement. And so then it just sort of travels its way up this conveyor and kind of daisy chains over, and then again daisy chains over. And you can see how, if I move this around, let me see, you can see how you can slide this around.
So one person can move it?
Yeah, one person can manage this from on top. And then I have a guy down below, and he just keeps this stuff full.
And let's just, from the sustainability standpoint, let's just talk about why that's important, as far as, like, if you compared it to like rammed earth, of course, you've got a bobcat or something like that moving material to be able to load it into the forms in the wall. In this case, it seems like this is very low impact. Like, can you raise this up, or?
Yeah, well, you can see that there's a boom here, and the whole thing raises up. And in fact, is this middle conveyor, it also raises up, so you can walk underneath it. It doesn't interfere with the construction site. And
what's the height of wall that works with this machine?
You know,
more or less.
I'm kind of limited to about 14 feet with this right now. Most projects go a little over 14, but it's usually a fireplace or something like that, and we just bucket it up there. It's very simple.
So you're saying if you wanted to go 2 stories, then you could have some kind of system where you're actually bringing the material manually?
Yes, or you could do this in a couple stages. And I've got another machine that's under design that will bring me up to those levels, but it's not completed yet.
One point I want to definitely make here is because there's a big trend with 3D printers. And when I saw this initially, I think I talked to you about this, I was kind of thinking like, wow, that technology is really taking off, robotics and 3D printing. Do you see this fitting in with that?
Well, this is actually, I would call this the early cousin to the 3D printer, because this conveying mechanism takes all the drudgery out of construction, like the computer would. In this case, I'm going into a wall, and I have things going on in here in this wall, conduits, electricity, other kinds of utilities that I need to manage a little bit anyway. So I need to be here anyway. But all of this hard work is sort of done for me, which is, I just kind of drag this around.
And so, of course, the other big trend that we're seeing is the whole DIY movement. People, watching a YouTube video and then building a house from that. How does this fit in? I mean, this is a big machine. What are your plans for smaller scale type do-it-yourself development?
Well, in order to develop this industry, I needed a machine, and I needed a machine that would be efficient for me. Therefore, you got a big one right here, and that's what this does. I built this. So, but it doesn't work for everybody. I mean, this system, building a sandcastle, is intentionally so simple that anyone knows kind of how to do it anyway. Just as a child, you could probably be helpful on a construction crew. So I've got another mixer that I've been working on that's just a little pull around behind any small pickup truck that would give you this same batch. And you could throw it up there with buckets. I mean, I have done complete houses as big as Maru, not Maru's, but as big as Maru's, using 5-gallon buckets. Yeah. I mean, there was a lot of people involved. I mean, this machine, I need 2 people. That's useful. That just reminded me of another question. So what if we're off grid with this machine? Could you operate this off grid? Yeah, this machine has an onboard generator. Okay. And so although I have built this machine for electric power for 2 reasons. One, I could do solar in the future, but mostly it's quiet. There's usually power on the job. And so this machine sounds more like a ski lift when it's running. Just all you hear is all these little rollers. But I can turn this generator on and I can run it and run it all day long. All this talk about seeing this thing work, I really want to see it. I think our audience does too. Is there any way we could maybe fire this thing up and see it work? All right, great. Let's go ahead and get set up for that. I'll go ahead and talk this too. It turns on the belt right now. And this is the mixer. And this comes on up here. Drops off from conveyor to conveyor. Works its way around. Paul, this was amazing. I'm totally blown away by this. I really appreciate you taking the time to show the project as well as the process and the material. I hope we can do this again sometime, and I really hope that you will thank the owner for opening their home to us for this experience. Will do, sure. And thanks for coming by. And I'm glad you to be spreading this around. Thank you. Good to see you, Paul. You too. I appreciate it. Bye. So another example of sustainability right here in Tucson. One thing before I go that I'd like to touch on, that's another strategy that's right here in this project, and I figured we should talk about it, is the configuration of the buildings and creating this courtyard. This is a microclimate. You can see how lush it is. It's protected by from the wind, and so all of these plants are creating a cooling effect in this climate. And this is used in a lot of other areas. We could do a lot more of this locally here in Tucson to create these kind of microclimates and cool spaces that we can enjoy in the summertime even. So with that, I'd like to thank you for attending this lecture series, and we'll see you on the next one. Thank you.